Hello and welcome guys to another video of reinforcement learning. So from this video onwards, so we will be only learning the algorithm part mostly, as well as some minimal concepts of other things. So first algorithm is Q learning. So for every algorithm we will be first covering the theory part, and then we will see the implementation in Python, followed by all the necessary information required. Okay, so the very first algorithm is Q learning, is the basic algorithm of reinforcement learning. So what is Q learning? So Q learning is a popular reinforcement learning, so used for learning the optimal policy in an agent environment, basically interacting. So so for example, so suppose you have a robot agent that need to navigate a grid world environment to reach a goal state while avoiding the obstacles. So the agent can move in four directions: up, down, right, and left. So at each time step, the agent observe its state, or basically its position in the grid world, and take an action like moving one of the four directions. Okay, so the agent receive a reward for reaching the goal state and a negative reward for hitting an obstacle. Okay, so initially the agent does not know the optimal policy to reach the goal state. Okay, so it start with a random policy and begin the exploring the environment by taking action and observing the resulting state and reward. So basically, overall, if I say what is Q learning, so Q learning is a algorithm that updates the agent Q value for each state action pair based on observed reward and the expected reward from the next state action pair. Okay, so it uses a Q table. Okay, so let me show you how it looks. So obviously I have show it to you in the previous video also, how the Q table looks like. Okay, so the Q table represents the expected cumulative reward for a reward of taking a particular action in a particular state. Okay, so the equation that you have seen here, this one, let's understand it better here. Okay, so I have wrote in a layman method. So what is this I mean formula? So basically you maybe have familiar with the the formula that you see here. You must have seen in the state action videos where I have explained the same thing. So let's explain again. Okay, so here basically the QSA that you see is a Q value for taking an action A in state S, whereas R is the receive reward for taking that particular action A in state S, where S dash is the next state. S dash that you see here is the next state observed after taking action A in a state S, where A dash, okay, it should be A dash here, and so basically A dash is the next action taken in the state S dash, and the alpha that you see is the learning rate. Okay, so uh, so basically the learning rate determine the extent to which new information overrides the old information. Okay, and the gamma that you see here, this one, is a discount factor that determines the importance of future rewards. So the as the agent explores the environment and updates its Q value, it gradually learns the optimal policy to reach goal state. Okay, so the agent select actions based on the highest Q value for the current state, and the continue updating its Q value as it interact with the environment. So basically what is Q table? So Q table is nothing, just a data structure that the agent uses to store and update its Q value. Okay, and basically what is Q value? So Q value represents the expected cumulative reward of taking a particular action in a particular state. Also you can say Q table is a matrix. Okay, we have seen in the examples also, like how we define it, right? Either we create a list, or some in the format of zeros and all that. Okay, we have seen in the matrix form as well using numpy. So basically this Q table is a matrix where each row correspond to state and each column correspond to action that can be taken in that state. So the value in each cell of the matrix represent the q value for the state action pair. Okay. So basically during the learning process, the agent update the queue table after each action based on the reward that it has received and the expected future reward. So the updated queue value is stored in the corresponding cell of the existing queue table that has been created. So as the agent continues to explore the environment, the queue table get updated and get more accurate. Okay. So eventually the queue table will converge to the optimal queue value, and the agent can use it to determine the best action in that given state. So in summary, the queue table is just a data structure used to you know used in queue learning that store the updated expected cumulative reward for each state action pair, which the agent can use to determine the optimal policy. Okay. So the last thing that I wanted to just tell about the queue learning. So the queue learning learns the optimal policy relentlessly, because the estimate of queue value are updated based on the queue value of next state action pair, assuming the greediest action to be taken subsequently. So what I mean by greediest action, it will take the max value. Okay. So let's understand the algorithm step by step. Okay, working basically. So what we do first we initialize the queue table with zeros, or when we generate a matrix in numpy. So what we do, we like generate np dot zeros, and we pass what is the size of the matrix 4 comma 2, like that. So like that we will be initializing the queue table with zeros for each state action pair. Okay. And then after that we will observe the current state S. Okay. And we will choose an action A based on the current state S and the exploration strategy, that is epsilon greedy. Okay. Now after that we will perform the chosen action A, and the and we will observe the new state S dash, and and also observe the reward. After that we will update the q value for state action pair SA using the Bellman equation, the equation that you have seen there as well. Okay, it should be A dash. Yeah. Okay. So after this, yeah, where all the information you already know what is all this. So alpha is basically learning rate and gamma is discount factor. Okay. So then we set the current state S to the new state S dash, and we repeat the step you see here, like up to 3 to up till here, Bellman equation. Up till here we keep repeating until the episode terminates or the maximum number of step is reached. Okay. And after we reached here, for multiple episode, so you will see that our q value has been converged to optimal value, and that is what the q learning algorithm tells us. Okay. So to summarize basically, so it involves updating the table of q values which represent the expected reward for taking a particular action in a particular state using greedy approach, and at each time step the agent selects the action based on current state and the q value, and then take the action and observe the resulting reward and new state. Okay. The q values are then updated based on the observed reward and the estimated reward, using the learning rate and the discount factor, and the process get continue until q value converts to the optimal value. Okay. So this is how it works. So let's see the implementation in Python in the next video. Okay.